Nur Iza Hakimah. Nur Iza Hakimah. Nur Iza.
Yes, Doctor.
Oke, attendance ya. Tanya, oke. Raja Ahmad Zahid.
Iya, Doctor.
Attendance. Ho Jeng Hen. Ho Jeng Hen. Ho Jeng Hen. Azizun. Azizun. Ibrahim Hassan. Ibrahim Hassan.
Yes, Doctor.
Right. Sadnan Sakib.
Yes, Doctor.
Ho Jeng San. Ho Jeng Han.
Hello, good morning, Doctor.
Shafika. Nuraina Shafika. Nuraina Shafika. Andrin Justin. Andrin Justin. Wei Junmo. Wei Junmo. Ya.
Hello, Assalamualaikum. Saya Aimi, buat panggilan dari KM Unify. Boleh saya bacakan dengan Encik Muhammad Fuad bin Rahman?
I busy ada kelas.
Oh, okay.
Wei Junmo,
Yes, sir.
are you in my class?
Yes.
Your name is not inside.
More way June.
Oh, Wei Jun. Oh, I see.
Okay.
You menyam. Chinese dia punya surname kat belakang. Okay, sorry. Nur Aina Syafika. Nur Aina.
Yes, Doctor.
Okay. Attendance-nya. Tunggu lagi 1 minit. Aina. Aina I18 KI. Aina. Aina. Aina Nabila.
Yes, Doctor.
Adam Mazlan.
Ya, Doktor.
Attendance. Full name apa?
Muhammad Adam bin Mazlan.
Omar Adam.
Ha.
Tak telefon. Omar Adam.
Muhammad.
Muhammad. Muhammad apa?
Ha.
Muhammad
Adam.
MU
MU.
Okay. Telpalgil.
Here, Doctor.
Are you there?
Yes, Doctor.
Ali Imran. Ali Imran. Alisha Zaidi.
Yes, Doctor.
Full name?
Nur Alisha Ahmad Zaidi.
Nur Alisha. Omar Ashraf.
Yes, sir.
Muhammad Ashraf.
Yes, sir. I'm here.
Arabs from Yemen.
I'm from Egypt.
Egypt. Ahlan.
Yes, sir.
Teo Sun Yi.
Yes, Doktor.
Okay. Ala Al-Fahad.
Yes, Doctor.
Farah Arisha.
Yes, Doctor.
Nama tak ada. Farah Arisha nama tak ada. Full name apa? Ni Umar.
Hello.
Present, Doctor. Sorry.
Ni Umar.
Yes, saya. Nick Umar present.
Full name?
Nick Umar bin Nick Muhammad Nizam.
Muhammad Safwan.
Present, Doctor.
Tian.
Present, Doctor.
Ni Umar iPad.
That will be me too.
You have to.
Yes. The device connected.
So you have Ni Umar iPad is your siblings.
No, I can communicate with my computer.
Okay, that is the. Shall we start now because it's 2+11. Bismillahirrahmanirrahim. Good morning. Assalamualaikum and good morning. So last week I discussed with you the preliminary chapter 1 on the root locus method. where root locus is a powerful graphic method of analysis and design for stability and transient response of a control system. And it also a representation of a closed loop pulse as the system parameter is varied. What is the varied parameter? That is the gain key. So the concept of the root locus is based on the closed loop pulse, where we have to find the gain key. Okay, find the gain k. So each gain k will give you a different closed loop pulse. Okay, as shown in this diagram, slide number 9. So we have one examples, which is k divided by s squared plus 10s plus k, where k1 is the controller gain and k2 is the system gain. So we consolidate. Consolidate tu maknanya cantumkan, combine. The gain become k, where k is equal to k1 plus k2. Right? And then we obtain this kind of plot, okay, which is the root locus plot, which is the red color. Okay, so it start from the -10 towards the right and 0 towards the left, and then they met at the breakaway point, which is -5. So after they met in the breakaway point, one split to the north, ended at infinity, and the other one ended to south, ended to infinity as well. So we can plot this using a MATLAB, okay, by using this kind of MATLAB command and double prompt, where numerator is equal to 1, denominator is equal to s squared plus 10s plus 0. So R locus, which is the command function for the root locus. So you will get this kind of plot. And this plot actually is the S-plane. Okay, it shows the position of the closed loop pulse, the open loop pulse, and then there is a, what do you call that? The grid. The grid is not like a linear grid, but the grid is a straight line, like a sunbeam, which represent the damping ratio, and the circle line, like a unify atau Wi-Fi beam, which is represented by the undamped natural frequency or omega n. Okay, so we go through the examples, and then the important concept of the root locus is the magnitude and the angle criterion. So the magnitude is represented by magnitude k GHS is magnitude is equal to 1, and the angle of k GSHS is equal to 2k plus 1, 180 degrees. From this, we can simply obtain the gain k, which is k is equal to 1 over modulus or magnitude g multiplied by h. Okay, so I give you one examples of this k over ss plus 10. Okay, and it seems that this one, this point, or minus 947 and minus 0.53, substitute to the KDS and is equal to -1, and it satisfies the magnitude criterion. Then I give you another examples, which is this one, k s plus 3, s plus 4, and over s plus 1 and s plus 2. So we test whether -2 plus J3 is it in the closed loop pulse. So after we test it and using a angle criterion, it is not minus 180 degrees. So the point is not on the root locus. And then we try another one, which is -2 plus minus J 0.707. Okay, so have you prove it? Okay, did you prove it? This one, -2 plus J1. Dah buat?
Yeah, I did it, doctor. Yes.
Yes, okay. So let me draw to remind you again. Okay, so I -4, -3, -2, and -1, and then the test point is at -2 plus j plus j 0.707. Okay. So let me share with you with my okay. Can you see?
Yes, doctor.
Can you see, guys? Okay, thank you. Okay. Then you have theta 1, theta 2, theta 3, and theta 4, respectively. Okay. Right. So now you have to find the theta 1, theta 2, theta 3, and theta 4. So theta 1 is the easiest one. Theta 3 is the easiest one, which is 90 degrees, correct? Okay. How about theta 1? Theta 1 is
19.46, doctor.
tangent 0.707 divided by
2.
what do you get?
19.46.
90.
19.
19 point. Okay. Theta 2 arctangent 0.707 divided by 1. What do you get?
35.26.
40?
35.26.
35.26. And theta 4? What is theta 4 values?
I got 144.74.
Arctangent
0.707 divided by 1.
divided by 1. 100?
44.74.
144.
Yes.
Point?
144.74.
Okay. So you already get theta 3, theta 1, theta 2, and theta 4. Okay. And then the formula is say that theta 1 plus theta 2 minus theta 3 minus theta 4. So you get 180 degrees.
You got negative 180 degrees.
Okay, okay. Negative 180 degrees. So therefore, minus 2 plus j 0.707 is the point on the root locus. Hashtag. Okay. So that's why we prove it. Okay. I hope you understand.
Yes.
Okay, so we carry on with the how to calculate the after we confirm the angle criterion is minus 180 degrees, and we confirm already. Okay, it's proof already. Okay, by formula and all the Pythagoras theorem, arctangent, and so on. And then we have to calculate the value of gain K on that particular things, okay, on that particular point. So what is the gain value? Okay, gain value of K on minus 2 plus J 0.707. Okay, so we use the formula K, which is equal to 1 over magnitude GSHS. And then we have these symbols. Nak tanya lah. Law Zhoutian. What is the meaning of this symbol?
The it's not summation.
Summation ni macam ini macam
Yes.
Multiplication.
the product. Okay.
Yeah, product.
Pole length. So pole is here. Okay, so pole is here. What is the distance of this? The length is 0.707, which is this one. 1.22 is this length. Okay. So how we get 1.22?
Pythagoras.
0.707
square plus 1 square, then root over.
L4 is equal to square root 1 square plus 0.707. So you get 1.22. Okay.
0.707 square.
Sorry. Make sure that students are not sleeping. So you are highly aware about it. L2, Luqman Al-Hakim, L2, give a try, salah tak apa. L2 same like L4, okay, same 1.22, and Luqman tak cakap pun. L1, Man, oh Luqman, puasa dua kan? Betul. 707 square. Okay. So you get 2.12. Okay. That's why you dapat the gain is 0.33. Okay. At minus 2 plus j 0.707. The point is on the root locus and the value of gain k is 0.33. Got it? Inshallah. Got it. Okay. Alright, brothers. Fahim tak? Alright, brothers. Fahim tak?
Yes, doctor.
Naam, Inshallah, naam. So we can prove it by calculations, and at the same time, we can prove it using a coding, MATLAB coding. Okay. So just now I discussed with you this point last week, and minus 2 plus j3 is not on the root locus. Prove it. We prove by calculation. Prove it by coding, by computer programming. So this is the way. Okay, we prove it. So we prove the theta. The angle criterion is minus 70.56. Okay. So first we wrote the poles, the point, the test point value, and then we wrote the transfer function, and then we use the criteria angle 180 divided by pi multiplied by angle G, then absolute G, okay, and then K is equal to 1 over M, which is minus 70.56. It's not on the root locus. Then second point is minus 2 plus J, 0.7071. Okay, again we put another value, the new test point value, put on the same transfer function, use the same formula for M and for the K, and then we prove it that the theta is 179.999993, which is more or less round up 180 degrees. Oops.
Doctor, can I ask why is the M and N? The M represent for what?
M represent for the
Absolute.
Absolute is the function in the MATLAB. So let me go to the MATLAB. Help ABS.
Actually, I know what is the function of ABS, but I don't know why.
Absolute value of the element X. Like a modulus or magnitude of the element.
What I don't understand is the absolute of the transfer function. So after absolute, what will happen?
Sorry, again?
After absolute, the transfer function, what will happen? This one I not understand. Because if, according to the calculation, is the multiple of the 4 length over the multiple of the 0 length. But then if in the MATLAB code use the absolute, this one I don't understand.
It's the simplifications of the Pythagoras theorem in order to find the length.
So directly can use the ABS.
Yeah, directly. Okay.
Okay.
Right. So in vector representations of a complex number, if we have a complex number, for example, Fs, okay, product of zeros divided by products of poles, okay, in the numerators complex factors and denominator complex factors. So the magnitude will become the product of zero length, okay, the length between the zeros towards the test point, and divided by the product of length between the poles to the test point. Somebody please close the mic, please. Theo, close the mic. Thank you. And then angles, which is summations of zero, angles minus the summation of poles angles, then we get the theta value. Okay. For examples, okay, this is the example 1 from Norman Nice book by given a unity feedback that has the forward transfer functions. Okay, so this is the forward transfer functions. Zeros, open loop zeros at -2, and you have a complex conjugate poles here. Okay, the roots is by using calculator is -2 plus minus J3. Okay, so in the poles and zero form, it is represented by these transfer functions. Okay, so determine if a point of -3 plus J0 is on the root locus. If the point on the root locus, find the gain K that satisfies the requirement. So again, this is the same example as previous examples, but different transfer functions. So your test point is -3. And then this is the transfer functions. So the answer is yes. And based on that -3 points, we calculate the length, and then we obtain the K is equal to 10. Okay. So did I show the examples? Okay, so here you are. So -2, zeros at -2 is here. Okay. This is -2, zeros. And this one is the complex conjugate poles. Okay. At -2 plus J. I forgot the value. Okay. Something tadi. Okay. So this is the test point at -3. Okay. So again, we have 3 length, L1, L2, and L3. Okay. So by using a angle criteria, okay, so the angle of zeros due to theta 1 is 180 degrees. And then for theta 2 and theta 3 is -108.5 and -251.5 respectively. and the total is minus 180 degrees. So confirm that minus 3 is on the root locus. And then by using the magnitude criteria and gain formula, so we obtain the value of k is equal to 10. Okay, so the length L2 is 3.16, 3.16. L3 same, 3.16, because both are complex conjugate poles. And the length of zeros towards the test point is 1, so k is equal to 10. So this is the graphical of the root locus, okay, of that examples where the gain is 10, open loop pole minus 3, the damping is 1, okay, and overshoot is 0, and frequency at that particular point is 3 radian per second. So this line, okay, the circle line is 2. This line is 4. So in between, okay, there is a line there between 2 and 4, okay, which represent a 3 radian per second. This is the omega n value of the system, okay, at that point. Example 2, so given a unity feedback, again, different transfer functions. So this time around, we have minus 2 zeros, minus 10 poles, and this one is plus minus J3, and this one, somebody can factor what is the open loop zeros for this, s squared plus 2s plus 17. What is the open loop complex conjugate zeros? Somebody press calculator, please.
-1 plus minus 4j, then 4i.
Thank you, Isha. Thank you, highly appreciate. Right, so you are required to find the gain key, okay, if the closed loop poles at -9. So first we have to confirm that -9 is on the root locus using angle criteria. And then after you confirm that, you calculate the length, L1, L2, L3, L4, L5. So we have how many length here? 1, 2, 3, 4, 5, 6, 6 length. Okay. So L1, L2, L3 due to zeros, 3 zeros, open loop zeros, and L4, L5, L6 is the length due to the 3 poles. Okay. Right. So this is the explanation for it, and this is the test point, -9. Okay, star. And this is the poles. Okay, complex conjugate poles. And this is the complex conjugate zeros. Okay, yeah. Then you start to draw, okay, using your ruler or whatever tools you have, okay. Okay, something like that. Okay, and then the point is on the root locus based on the angle criterion, -180 degrees, and for that purpose, we use the gain k, which is product of pole length divided by product of zero length, which is k 0.161. Okay, and then you can prove it using graphical MATLAB. Okay, and it's confirmed the value is 0.1607 or 0.161. So some tutorial for you to test, okay, your angle criterion and your magnitude criterion, okay, and the gain formula. So I just leave it to you. And then to construct the root locus, we must have rules, okay? These are procedures to construct the root locus. The following rules allow us to sketch the root locus. After sketching, the root locus can be refined. So first, you mark the open loop poles and zeros on the S-plane, okay? So usually we use the S-plane to plot it, okay? The location of open loop poles and open loop zeros. And then rule number one is number of branches, okay? So root locus have a branch. So the number of branches are equal to the number of open loop poles, okay? So in this case, for example, this one, okay, the highest is S square, am I right? So meaning that it have a two branch, okay? How about this one? The highest multiplication, you get S cubic polynomial. So you have a three branch, okay? And then rule number two is symmetry. So the root locus is symmetrical about the real axis. For example, if you look here, okay, you can see that based on this real axis, okay, real axis. So if you flip this one towards this one on the real axis, so this point will meet this point and the poles will meet this point. So meaning that it is a symmetry, okay, at the real axis. Rule number three is the real axis segments. So on the real axis, for k greater than 0, the root locus exists to the left of an odd number of real axis finite open loop poles and zeros, open loop zeros, okay, which is the odd number, nombor ganjil, okay. Example, rule 1 and rule 2. So you are given the same transfer functions as before, which is that s squared plus 10s plus k. So this is the plotting of the root locus, okay. So two branches are shown, originate from origin of -10 due to open loop poles, okay. So you have -10 and zeros, okay. So you can see that the plot of the root locus, okay, since we have only two poles, okay, two open loop poles, open loop, two poles. So the root locus will start from the poles, okay, -10, and start from the poles at zeros, and then they will meet at -5, which is the breakaway point. Okay, one goes to the north, one goes to the south, and ended at infinity. Okay, so this shown that the symmetrical about the real axis. Okay, so this is the real axis. Okay, so when you flip this one, the positive side to the negative side, so you will get the same branches and plotting each other. Okay, they adalah symmetrical. So rule number 3 is say that on the real axis for k greater than 0, positive gain, the root locus exists to the left of an odd number of real axis, finite open loop poles and zeros. Okay, so we have k, s plus 3, s plus 4, and s plus 1 and s plus 2. Okay, so you can see that on the real axis for k greater than 0, root locus exists to the left of -1 and -3. So in this case, okay, if we have this kind of transfer functions, we have here, Okay. The root locus will start at -2, will start at -1, and then it will have a breakaway point here. Okay. So it will not end at infinity. Okay, it will end at the zeros because that is the root locus procedure. Okay, because we have a zeros, and then one will go to the left, ended at -3, and the other one will go to the left at -4. Okay, so this one is a breakaway point. Okay, and this one is what we call as a break-in point. Okay. Break-in. This one is breakaway. Okay, as I told you before. Okay, so when we draw the root locus using a MATLAB, so you can see that the plotting. Okay, in MATLAB they didn't show the directions of the root locus. So in the class, I will tell you that the root locus start from poles. Okay, start from poles. Then they met at the breakaway point here. Okay, one goes up, one goes down, and then they met again here at the break-in point, and one will go to the right, ended at 0, -3, and the other one will go to the left, ended at -4 zeros. Rule number 4 is starting and ending point. So the root locus begins at the finite and infinite poles of GS and HS at k is equal to 0 and ends at the finite and infinite zeros of GS and HS at k towards the infinity. For example, you have open loop transfer functions, which is a k s plus 1, s plus 2, which have 3 finite poles and 3 infinite zeros. Okay, so the finite poles is 0, -1, -2. So where is the infinite zeros? Rule 5 will help us to locate these zeros at infinity. So this is the transfer functions. So you multiply. So you multiply, you will get s cubic plus 3s squared plus 2s plus 0. Okay. And then you use rule number 4. Okay. So you will get this kind of plot. These poles and zeros are the open loop poles and zeros. The root locus begins at the finite poles at -1 and -2 and ends at the finite zeros at 3 and -4. So in our case, okay, just now, which is s cubic plus 3s squared plus 2s plus 0. So first we plot the root locus, okay? We plot the root locus. So in this subject, you are not required to plot root locus in test and in the final exam. The plot will be given, okay? You just know how to extract out informations from this given plot, okay? So for example, I have this plotting, okay? So how can I, what do you call that? Plot the root locus, okay? So let me share with you the how to plot it. Okay. Can you see?
Yes, Doctor.
All right, thank you. So there are two ways, okay? So if you want to plot it, you open your MATLAB, okay, double prompt, okay? You just wrote there STF, okay? S equal to TF, bracket, apostrophe S, apostrophe, bracket, apostrophe, and then G is equal to, this one you assume as 1. Okay, assume as 1. So 1 over S cubic, okay, plus 3 multiply S square plus 2 multiply S, close bracket. Okay. Then R locus G. Okay, only 3 lines. Okay, then you will get this kind of graph. Okay, which is the root locus of the examples given. K divided by S, S plus 1, and S plus 2. Okay. So as I told you before, root locus start from poles and ended at zeros or infinity. So in this case, there is no zeros. Okay. So all the branches of root locus is 3 because the highest is 3. Okay. So you have 3. 1, 2, 3. Ahad, Isnin, Selasa, San. And so start from here. Sorry. Okay. So start from here. 0, -1, and -2. So the start from the poles, -1, start from zeros, and then they met at the breakaway point. One goes to the infinity, and the other one go down to infinity. Okay, so and then the -2 also no friends, no zeros, so he also ended at infinity, like that. Okay. Okay. So behavior at infinity, the root locus approaches straight lines as asymptotes as the root locus approach infinity. Number of asymptote is equal to the number of finite poles minus the number of finite zeros. So in our case before, poles is 3, zeros is 0. So 3 minus 0, so number of asymptotes is 3. And the real axis-intercept is sigma A. The formula is summation of finite poles minus finite zeros divided by finite poles minus finite zeros. And then it will give you the angle value, which is theta A, which is equal to 2k plus 1 multiplied by pi, which is 180 degrees, divided by the number of poles minus the number of zeros. Okay, so at rule number 5, you have a break. Okay, about 10 minutes. Boleh? 10 minutes break.
Okay, Doctor.
10 minutes break. You don't have to go out lah. You stay je lah. Boleh?
All right.
Muhammad Mutasim.
Yes, sir.
It's not inside. Muhammad. Okay, find it. SKEL. Abdul Rahman Sharum. Sharudin. Muhammad Ammar.
Here, Doctor.
Okay. Yosef. Yosef.
Yes, doctor.
Full name Yosef.
Yusuf Ahmed Juma.
Okay. Abdul Azim.
Yeah, Yusuf Ahmed Abdul Azim Muhammad Juma.
MashaAllah. Have a long name. Yusuf Ahmed Abdul Azim Muhammad.
No, it's not only my name. It's my father and grandfather indeed.
You forgot to put Sheikh. Sheikh Yosef. Ahmad Abu Ilad. Ahmed Abu Ilad.
Yes, sir, I'm here.
Name also not inside. Ahmed. Full name.
It's Ahmed Al-Amir Abu Lat.
Find your name. Ahmed. Ahmed Al-Amir. Ahmed Al-Amir. Sheikh. Ahmed Abu Ilad. Ahmed Al-Amir. Nur Farah Risha.
Yes, Dok.
Attendance. Asim. Full name.
Asim Jamil Ahmed Thabit.
Asim Jamil Ahmed Thabit Al-Qarshi.
Yes.
MashaAllah. Imran Hakimi.
Yeah.
Are you from Arab? No?
No, Malaysia.
Azira Ahmad.
Yes, sir. Yes, sir.
Azira.
Yes.
Yes. And Mek Hassan. Who is Mek Hassan?
Yes, Doctor.
Full name?
Hassan Muhammad Sheikh Al-Kaf.
Hassan Muhammad Al-Sheikh Al-Kaf.
Yes.
And Muhammad Safwan.
Yes, sir.
Muhammad Safwan.
Doctor, for Ahmad Al-Amir, he has a problem with his mic. He cannot answer.
Okay, ask him to replace a new one. Okay. Omar Muhammad Ali Abdul Latif. Omar Muhammad Ali Abdul Latif. Absent. Muhammad Akmal Zulkarnain. Muhammad Akmal Zulkarnain. Absent. Arunab Das. Arunab Das.
Yes, Doctor.
Okay. Amirul Hazim Amrin. Amirul Hazim Amrin. Amirul Hazim Amrin. Absent. Muhammad Rafizat Achwan. Muhammad Rafizat Achwan. Absent. Sharir Mahmud Fahim. Sharir Mahmud.
Yes, sir.
Adnan Firdaus Ahmed. Adnan Firdaus.
Yes, sir. I'm here, sir.
Ismail Mubarak Saleh Al-Haddad. Ismail Mubarak Saleh Al-Haddad. Ismail Mubarak Saleh Al-Haddad. Absent. Osama Bilhaj.
Yes, Doctor.
Shukran. Abdul Ghani Said Othman Al-Mudi. Abdul Ghani Said Othman.
That's shocking. I'm so surprised.
Abdul Ghani Said. Absent. Muhammad Khalid Abdul Muntasir. Muhammad Khalid Abdul Muntasir. Muhammad Khalid Abdul Muntasir. Absent. Abdul Rahman Hamdi. Abdul Rahman Hamdi. Abdul Rahman Hamdi. Absent. Abdul Iskandar Zulkarnain. Abdul Iskandar Zulkarnain. Absent. Khalid Ahmad Khalil. Khalid Ahmad Khalil. Khalid Ahmad Khalil. Absent. Muhammad Haikal Shah. Muhammad Haikal Shah. Muhammad Haikal Shah. Absent. Muhammad Haziq Hashim. Muhammad Haziq Hashim. Absent. Muhammad Luqmanul Hakim.
Yes, Doctor.
Ahmad Azmi Abdul Hamid. Ahmad Azmi Abdul Hamid. Ahmad Azmi Abdul Hamid. Absent. Okay, so we continue our lecture. Okay, the rule behavior at the infinity. So example of rule 5. Okay, so rule 5 is using the same transfer function, which is the k over s plus 1, s plus 1, and s plus 2. Okay, so you have a, sorry, is using which number, this one? This one. Okay, s plus 1, s plus 2, s plus 4, and 0, f minus 3. Okay, so you sketch the root locus, which is here. Okay, so you can see that the asymptote is 3. Okay, which is shown here. Asymptote is the line. Okay, a guiding line for the root locus plotting. Okay, so the root locus will not hit this asymptote line, because asymptote line is like is the boundary. Okay, a guidance for the root locus branches to flow apart. So as I told you before, based on this okay, we have open loop zeros, -3, and open loop poles at 0, -1, -2, and -4. Okay, and this is shown in the plot here. 0, -1, -2, -3, -4. So number of branches, okay, is still 3. Okay, branch. Sorry, it's not 3, it's 4. Okay, it's 4. This one is S4, so number of branch is 4. Okay. So the root locus will start from poles and ended at zeros or infinity. So in this case, we start from the imaginary axis, then we move towards the left, okay? So the first pulse is 0, and the second pulse is -1. So root locus will start from -1 towards the right, and zeros towards the left. And there is a breakaway point, okay? Breakaway point, because it goes away from the point, and that at infinity, and that at infinity. Finish. Okay, khalas. And then we move to the left again, and there is a -2, zeros, and zeros at -3. So the locus will start from -2 towards the left, ended at -3, because -3 is the zeros. Khalas. Okay, and then goes again to the left, and the only pulse left is -4. So -4 don't have any friends, even a pulse, even a zeros. So it will end it at infinity, right? So there are more open loop pulse than open loop zeros. Thus, there must be a zeros at infinity. Okay, the angles of the line that intersect is -4/3, which is the what we call as apa nama ni kita panggil sebagai asymptote, is an asymptote. So actually the this one actually is here. Silap correction here. Angles of asymptote is not here. It's at -1.33. Okay, correction please. This one is wrong. Okay. So using a MATLAB, we can plot the root locus as shown. Okay, this is one way, the first method. Okay, to plot it. Okay. Okay, the second method is you can use a program, which is shown here. This is first method. Okay, second method is S. Okay, G. 1, we assume K as 1 first in programming. So S plus 3 divide, okay, bracket S multiplied by S plus 1 multiplied S plus 2 multiplied S plus 4 bracket, close bracket. Okay, and then R locus G. Okay. Example 4, okay, is another examples to construct a root locus. This time around, you are given an open loop transfer functions, okay, which is -2, -4, and -6. So open loop zeros not exist. And open loop poles 3, which is -2, -4, and -6. Okay. So verify your rule locus using a MATLAB. So can you do that? Boleh tak? Using a MATLAB.
Dr. Fuad, can you hear me?
Can't hear you. Somebody is.
Yeah, Doctor, I think you called my name previously, but my microphone doesn't work. So now
Okay. Never mind. Small matter. Keep focus. S+2, S+4, and S+6. Okay. So you're required to to sketch the rule locus using a MATLAB. Okay. So first we have to find the asymptotes. Okay, so the asymptotes is can you see this slide? Sigma A. Okay, sigma A is the asymptote intersect point. Okay, which is the value of poles minus the values of zeros divided by the number of poles minus the number of zeros. Value and numbers is different. Value of poles is -2, -4, -6. From where? From here. Okay. -2, -4, and -6. That is the open loop poles. And zeros not exist. Okay. So -2, -4, -6. So -0. Okay, meaning that there is no zeros. So divide by number of poles and number of zeros. So how many numbers here? The number of open loop poles is 1, 2, and 3. 3, eh? The number of poles is 3. The number of zeros is 0. So 3 minus 0. So at the end is 6 minus 12. Minus 12 divided by 3 minus 4. So this point -4 is here. Okay, the asymptotic intercept point. Okay, -4. Then the angle of asymptotes is by using the formula, okay, which is theta A equal to 2k plus 1, okay, multiplied by pi, 180 degrees, divided by 3, okay, the number of poles. So pi divided by 3, 180 degrees divided by 3 is what? 180 degrees divided by 3.
60.
60 degrees. Pi 180 degrees. And the last one is 5/3 multiplied 180. How much, Telpal?
300.
Thank you, Tapal. Okay. So this is how we sketch the rule locus. Okay. Then we're going to plot it using a MATLAB. Okay, like this figure. So how we going to get this figure? So we have to use a MATLAB. Okay, so we go to MATLAB. Yeah. Okay, so you use my method. S is equal to TF. Okay. Then G is equal to K divided by S plus 2, S plus 4, S plus 6. Assume K equal to 1. So 1 divide S plus 2. Okay, so another bracket, open bracket. Okay. S plus 2 multiply S plus 4 multiply S plus 6 close bracket, enter. Okay, and then R locus function G. Okay, enter. So wait, the computer is calculating. Can you see that? Busy. Okay, busy. So calculating. Okay, so now I share this one, the plot figure. Can you see the figure? Everybody, can you see the figure?
Yes, doctor.
Yes, doctor.
Yes, doctor.
Yes, yes.
Bigger, 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 bigger. Okay.
How do I get grades?
You see, look great. So you have a mouse here. Can you see my mouse?
Can, doctor,
Yes.
can. Yes, doctor, can see.
Left mouse and right mouse. So you just click the right mouse. Okay, you put the grid.
Oh, that's how. Okay.
Oh, very nice. Okay. Right.
Nice.
This is the way assignment you have to do like this. Okay. So I want to ask question. Nick Omar,
Yes, doctor.
the grid shown in the figure, you have what do you call that? Wi-Fi beam, Wi-Fi line, and sunbeam line.
Yes.
This is sunbeam. The other one is Wi-Fi beam. What this line represent for?
The beam, this is the damping ratio line.
Okay. And the
And
Wi-Fi beam?
is the value of undamped natural frequency.
Exactly.
Oh my God.
Okay, congratulations. Very
Thank
good.
you, doctor.
Right. And then, as I told you before, the number of branches is equal to the number of higher order of the open loop denominator. The bottom one, the bottom polynomial. So the highest is S cubic. Cubic is power of 3, S power of 3. So therefore you have 3 colors: red color, green color, blue color. Okay. And MATLAB don't have any arrow, so you have to put the arrow. Okay. My question is, my next question. Telpel,
Yes, doctor.
can I ask you a questions?
Sure thing, doctor.
What is the value of breakaway point?
The value of breakaway point, I assume, is 3.
So we're going to scan. Okay, you use your mouse.
Okay.
Magic mouse. You just click there. Okay, can see that. Then you press your left mouse. Then you move down, move down. You see the numbers. You see the data there. Gain is changing. Pole is closed loop pole is changing. Damping ratio is changing. So the break point will be here. Am I right?
Yes, doctor.
What is the breakaway point?
3.06
minus
negative
negative 2.78.
or negative 2.78.
Negative 2.78. You can see there is the info, the box info there. Okay, again, you just use your mouse, use your left click, click anywhere there, and then you press at this point, then you move up. Can you see the gain changing, the parameter gain changing? Am I right? At the same time, the pole, the closed loop poles also changing. Am I right? And then
Yes,
the
sir.
damping also changing, the damping ratio, the overshoot ratio, the frequency is also changed. Right? And we will stop here at the breakaway point. Slowly. Make sure that you do, make sure it is on the top of it. There you go, minus 2.85. Because at the breakaway point, there is no complex number. There is no J, only real number, which is minus 2.85. Correct? Sadanan Sakib,
Yes, doctor.
what is the value of the gain value at breakaway point?
3.08.
Thank you. Nur Farisha. Hello, Nur Farisha. Tak datang. Nur Farisha, call one.
Yep.
Tak datang Nur Farisha tak datang. Imran Hakimi.
Yes.
What is the damping ratio value at breakaway point?
Breakaway point damping ratio is 1 because it is on the x-axis.
Not x-axis, real axis.
Real axis.
X-axis tu linear graph. This is S-plane. Muhammad Safwan.
Ya, doktor.
What is the value of overshoot percentage at breakaway point?
0.
0%.
0%.
Okay. Next will be Abdul Ghani Said. Abdul Ghani. Not attend. Nur Izzah Hakimah.
Yes, doctor.
What is the value of undamped natural frequency at the breakaway point?
2.85.
Alah, wrong. What is the frequency value? Again.
2.85
radian per
second.
Radian per second. 2.85 and 2.85 radian per second is the two different answer. So I am very particular about the unit. Okay. 2.85 can be chicken. 2.85 can be lamb. 2.85 can be anything. Okay. So make sure you are precise. Right. So go to the slide again. So far, any question? Okay.
Okay, doctor.
So rule number 6 is the real axis breakaway and break-in points. Okay, so the root locus break away from the real axis at the point of maximum gain, and the breaks into the real axis at the point where the gain is minimum, which is the break-in point. So the breakaway point occurs at the point of maximum gain on the real axis between the open loop poles. The gain at the break-in point is minimum gain on the real axis between the two zeros. Okay, so this is the examples. Okay, break-in point, breakaway point. So how to differentiate between the break-in point and the breakaway point? The breakaway is depart from that point. The break-in point is entering. Okay, enter to the break-in point. The gain at the breakaway point is K maximum. K maximum. And the break-in point, the K, the gain value is minimum. To find the point of S is equal to alpha, where maximize and minimize of the gain K through differentiations, okay, where D over ds, GS, the open loop, we differentiate, then we equal it to 0, then we solve for S. The S that we obtain from the above equation is the breakaway point, which is alpha. Okay. For example, okay. So for example here, so we have how many breakaway point and break-in point? Ho Jeng Han. How many breakaway point and how many break-in point? Ho Jeng Hwan. Ho. Datang. S plus 1, S plus 2, S square minus 8S plus 15. Okay, so how we're going to differentiate?
Is it in the left plane?
Arrows of the thing, the arrows.
Yeah. Sorry? The arrows?
Only the left plane is valid.
Both plane are valid. Both.
Oh.
So this one is what? Pointing.
It's a breakaway.
Breakaway. BA, eh? So I use BA. Breakaway. This one?
Also breakaway.
Oh, it's break in. Break in, brother.
Oh, okay.
Because this one is, the arrow is away from the point.
It's in the right plane though.
Yes, so you can see that the arrow goes here, entering the point. Break in, the locus entering to that point. Okay. So now we are going to calculate this value, BA and BI, break away and break in, using the formula. What formula? This formula. Okay, this formula. Right? Okay. So go to iPad. Okay, differentiate. K GH equal to 0. So 2S U divided by B. Am I right? Hello?
Yeah.
Everybody are quiet, eh? Hungry.
Yeah. I'm using MATLAB.
V du U dv, am I right? Divide by?
Yes.
Divide by 0, equal to 0, okay? So in this case, S square TS plus 32, S square plus 3S plus 2, am I right? U 2S minus 8, correct? Minus U, S square minus 8S plus 15. Okay, multiply dv 2s plus 3, correct? Everybody quiet again.
Not sure that's.
Sure.
We need time.
3s plus 2, s square plus 3s plus 2 square. Okay, and all of this equal to sifar 0 and
0.
now okay, you simplify this one. 2s cubic plus 6s square plus 4s minus 8s square minus 24s minus 16 minus 2s cubic minus 16 s square plus 30s plus 3s square minus 24s plus 45. Okay, equal to 0. Simplify. Okay, so when you simplify, you will get okay, like I did here. So you will get simplify, so you will get 11 s square minus 26s minus 61 equal to 0. Can you please use your calculator? Somebody? This is a quadratic equations. Akhi, please help.
3.82.
Positive, negative?
Positive.
3.82.
Negative 1.4.
Negative?
1.45.
1 point. So 2 points.
1.18 as well. Wait, never mind. That's something else.
Itu lagi ke Allah.
Sorry.
3.82, comma, minus.
Minus 1.45, doctor.
Sahih? Alright, brothers. Sahih?
Yes, MATLAB confirms. Sahih.
Yes, doctor.
ما في مشكلة. 3.82 minus.
Santa.
So one is positive, one is negative.
1.18.
1.18. MashaAllah.
I don't see that in MATLAB.
I even with my calculator, I don't get that. I get 3.82.
This is the correct answer. 3.82. 1.4.
Yeah, this is correct, doctor.
Everybody, please calm down. Okay, we use MATLAB. We use MATLAB. Okay. So how are you going to find roots in MATLAB? So you just type there P equal to 11 minus 26 minus 61. Okay. Roots. P. Everybody see? Can you see?
And
Can.
3.81 and minus 1.45. Okay. Bismillah. Ma fi mushkilah. Correct. The answer is correct. Okay.
Naam.
Santa.
Okay. So my question is, now we have positive and negative point. So which one is breakaway? Which one is break in?
The 3.82 is breakaway.
Oops.
The negative is breaking away.
Negative 1.45.
Negative 1.5 is negative breakaway.
Breakaway is
Negative 1.545.
1.445. Break in?
3.82.
Shukran. Jazakallah khairan. Okay. Correct. Everybody happy with the explanation?
Doctor, how do you know which one is breakaway and break in?
Okay. Here.
Without the arrows, how do we know?
Without the arrows? What do you mean without the arrows?
Now we know because there's an arrow showing that it's going away.
Okay. So first you.
But in MATLAB, there's no arrow, so I don't know which one.
In MATLAB, there is no arrows.
So how do I know which one is the breakaway point and?
So what is the difference between breakaway and break-in? Breakaway point happens between two poles. Break-in points happens between two poles. Okay. So can we plot so that everybody are happy about it? Okay.
Yes.
we plot using a MATLAB? Boleh? Can we plot it?
Sorry, doctor.
Yeah, sure.
Can. Sure. Can.
This one need more explanation because it's very hard to understand. So as G is equal to bracket. Can you see this MATLAB? S square.
Yes, doctor.
S square. S hat. Cat. S cat 2 minus 8 multiplied by S plus 15. Divide S cap 2 plus 3 multiply S plus 2. Okay. There you go. R locus G. Okay. Enter. So now I share the figures, everybody. Can you see the figures, brother?
Yes, doctor.
Ah, mashallah, mashallah. How to get the grid? Helpful. How to get the grid? Help me.
Right click.
Grid.
Right click.
Right click.
There you go. Okay.
Naam, naam.
So now there is two breakaway. One is breakaway, break in. Okay. So this one is the
Breakaway.
breakaway,
Breakaway.
BA. And this one is break
In.
breakaway and break in. What is the difference? Breakaway occurred, happened between two poles. This is poles, am I right?
Yes.
Poles, eh? So nombor tadi, what is the numbers that we calculate just now? What is the number we calculate just now?
Negative 1.45.
Negative 1.45. So can we scan? Okay, therefore, click that and we scan. Can you see the numbers? I'm moving my mouse now.
Yes.
Everybody?
Yes.
Very good. There you go. There you go. Minus 1.4. We calculate minus 1.45. So in Chinese, soy, okay. Minus 1.4, okay? So in MATLAB, didn't mention here breakaway or break in. So we must understand the concept. Then we scan again. Sorry, minus 1.45. So I overscanned already. So the real answer is minus 1.45. Okay, so you jot down the gain. The gain is 0.00862. Jot down. Damping ratio 1. Overshoot 0. Frequency 1.45 radian per second. So how are we going to find this point, Telpal? Break in. How
Can we scan from there as well and try to go down or?
Okay, I scan. Scan. Yeah. So we go around, kita jalan-jalan, okay. Okay, we jalan-jalan, and then, oops, we press the brake. There you go. 3.82, correct?
Yes, doctor.
We calculate positive 3.82.
Naam, naam.
From the computer simulation, also 3.82. Sahih, inshallah, correct. Okay. So the gain will be 29, maximum gain. The pole is, the break in point is 3.82. Okay, the damping is -1, overshoot 0, frequency 3.82. Alhamdulillah. Alhamdulillahirabbil alamin. Okay, very hard to explain with calculation proving, with computer simulation proving. So alhamdulillah, the answer is correct. Okay. Any question? Any question?
Doctor,
Yes.
is there any way for us to determine the breakaway and break-in without the graph?
Without the graph, by calculation.
How we do that?
Just now I
Did it just now.
Do we see just the positive and negative and then
Yes,
that's all?
This one, this is the open loop transfer function. Okay.
Okay.
S squared minus 8s plus 15, s squared 3s plus 2, k assume as 1. Assume k as 1, then you start differentiate. Okay. I show the differentiation just now in iPad. I will give you the recorded later.
Is there any possibility that the root will be both positive or both negative?
Yes. Yes. There is a possibilities.
I see. Right, thank you, Doctor.
You simplify the differentiation, then you get 11 s squared plus 26s minus 61. There you go. Or another example, if you don't want to use differentiation, you use this one. Okay, 1 over s minus 5, s minus 3, 1 over s minus 5 equal to alpha plus 1, alpha plus 2. Okay, let me show you here. Another option. Another options to calculate VA and VE, i.e. 1 over s minus 3 plus 1 over s minus 5, 1 over s plus 1 plus 1 over s plus 2. Okay. So I share. Okay, so you don't have to use differentiation. So you just wrote like this: 1 over s minus 3, 1 over s minus 5. This is due to poles. Am I right? Equal 1 over s plus 1, 1 over s plus 2. This is due to zeros. Okay. So you simplify this. Simplify this. Then you will get 11 s squared minus 26s minus 61. Okay. Then when you use your calculator, inshallah, you will get the answer same as differentiation method. Okay, so this is the computer generated for data breakaway and break-in points for the root locus. For assignments, it will be like this. Okay, how to prove the break-in point and breakaway point. So you can see that maximum gain, okay, happen at the breakaway point. Okay, and this one is the minimum gain happen in the break-in point.
Sorry, doctor.
Okay.
But for the previous data, can MATLAB deduce it, or we need to check it point by point?
You can use MATLAB, or you can use programs, or Excel also can, because
I mean, is there a function to generate it as a table, or we need to check the point like minus 1.41?
You mean in the MATLAB?
Yeah, or yeah.
In MATLAB also you can see the data. For example, this data, okay. Okay, you can see here on the right hand side there is a workspace. Okay, okay, the P and the P and the G, the answers. So you know that we have imaginary and exist. So you can type the real is equal to real. I think so. If I'm not sure, okay. Real data. So real data. Go to real G. I think so. No, not real G. Okay. Real data to real G. Imaginary maybe. Imaginary. IMG. I forgot the name. Oh, image. Okay, sorry. Imaginary. Go to image. iMac G. Okay. I forgot the answers there. Tab IMG. Okay. iMac G. Imaginary G. Okay. So there is a command for it. I forgot to generate the data, but you can just click here, P. Okay. So if you click the P, there you go. You have the point there. Okay, or maybe the answers. Okay, or G there, and S. Okay, so there is a way that you can generate the data in order to obtain the one that shown here. Okay, I will show you later in the next time because I forgot the command com for that particular way to calculate this. Okay, sorry for that. I forgot the command line, but you can generate using MATLAB. Okay, any questions?
Oh, clear.
Everybody happy?
Yes.
Okay, if no questions, so we stop here. Okay, so we'll see you again, inshallah, Wednesday. Wednesday at 12 o'clock. Tomorrow is holiday. It's the birthday of Sultan Johor. Okay, see you then.
See you, Doctor.
Okay, thank you very much.
Thank you, Doctor.
Okay, thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
See the chat.
Thank you, Doctor.
Thank you, Doctor.
Doctor, if our name not be called, what about the attendance?
Sorry?
Just now my name didn't get called during the attendance check.
Abdul Rahman, okay.
Me also, Dr. Ali Imran.
Where are you? The chat, doctor, you didn't mention my name. Okay. Sir, I haven't heard my name. Muhammad Mutasim Siddiq, already mentioned. Ali Imran, doktor jumpa Tesla kat mana? Merah Saga. Itu betul. Kat Melbourne, Australia during my daughter graduations. Tesla.
Nice, Doctor.
Nice, very nice. Mampu tengok, mampu lihat. Doktor angkat satu tak? Tak boleh. Minta maaf. Mahal sangat.
Don't think you'll ever see that here in like 10 years, 20 years.
Just my level, capability, Toyota Camry and CRV only. Berat tu kereta nak angkat H&M. Memang berat pun. Ahmad Alamer, okay, Abuleta, doctor, I can hear you, but my picture does not function. Okay, repair your mic, please. Thank you, doctor. That's very nice car too. All right, so see you on Wednesday.
Thank you, Doctor.
Assalamualaikum.
Thank you, Doctor.
Assalamualaikum, Doctor.
Waalaikumsalam.